Hello, this is Scholar Strife doing some math today. In geometry, we're going to be reasoning using properties from algebra. So we're going into that proofs thing. We're going to start off easy using some algebra problems. The addition property of equality, basically, let's say our equation is A equals B. Then we could add. Basically, we're allowed to add things to both sides of the equation. Subtraction property. If A equals B, then we can subtract from both sides of the equation. So remember, when we're trying to get a variable alone, we can add stuff to both sides, we can subtract stuff to both sides. If we were dividing by something, we would multiply. So if A equals B, then A times C. So you can multiply both sides by the same number. You can divide both sides. So if A equals B and C is not equal to 0, then you can divide both sides by that number. And then we have the substitution property. If A equals B, then I can replace, anytime I saw an A, I could say B, or if I say anywhere I saw a B, I could put A. So A can be substituted for B in any equation or expression. And then we had the distributive property, where if we had A times the quantity B plus C, then we use our rainbow here to multiply both A times B and A times C. All right. So we kind of know those, we just haven't seen them probably in this lettered form. But let's use them. Okay, so this is where our proofs are coming in. If you ever see this, write a reason for each step. Or if you just say prove, or if you ever see the word prove or proof, that means you're going to need 2 columns. You're going to call this first side statement, and then reason. And then we're going to copy down the problem. So our first statement, so always number your statements and reasons. So we have my first statement and my first reason. So I have 2x plus 3 equals 9 minus x. And why did we put that down there? So this first one is usually called given, because it was given to us. It's the problem. So the reason why I rewrote it is because it was given. Okay, and then we're going to solve it also. So we're going to solve the problem like normal. And the first thing I'm going to do, I'm going to add x to both sides. So I have 3x plus 3 equals 9. So this will be statement 2. So statement 2, how did we get from statement 2? Well, we added x to both sides. So instead of writing that, which property did we use? We used the addition property, because we were adding to both sides of the equation. So this is the addition property of equality. So for this first set of proofs, you may use the abbreviated addition property of equality or subtraction property of equality, and so on and so forth. But later on, we'll have to write it out. So 3. So our third statement, so I would subtract 3 from both sides, and I'll get 3x equals 6. So that was so how we got there was through the subtraction property of equality. So we added, then we subtracted. And then lastly, we're going to divide. So my fourth statement, if I had more space, so I'm going to go ahead and leave out the work and just put 4. So x equals 2. And that was from the division property of equality. So if you were writing out this proof, you would need all of this except that. Okay, so all of this is what you need to show your work and write out a proof. Alright, let's do another example. Okay, so we're going to rewrite it. So statement, reason. Okay, first one, start out with our equation. Original, -4 times 6x, -4 times 2 equals 64. And that was given to us. 2. Now, you can solve it however way you want it, but I'm just going to do distributive property. So I'll get -24x plus 8 equals 64. So that was through the distributive property. There's no shorthand for that, so you just say distributive property. And then we're going to subtract 8 from both sides. So subtract 8, and I'll get -24x equals 56. Okay. Oh, wow. Sorry, got interrupted. Sorry about that, I got attacked by a spider. Okay, here we go. Shoe versus spider. Shoe wins. Anyways, so our next step would be... Oh, wait. So we subtracted 8 from both sides. So this is the subtraction property of equality. And then our last step would be to divide. So we would get x equals negative... Well, this would be a decimal. Let's see what that is. 56 divided by -24 is -2.333 repeating, which is -2 1/3, which is -7/3. So that was, again, we used the division property of equality to get there. Alright. Let's move on. Next page. So a motorist drives at a rate of 5 miles per hour, slower than the speed limit S, for 3.5 hours. Distance traveled can be determined by the formula that. So they gave us the formula, solve for S, write a reason for each step. Okay, so write a reason for each step. So we divide our two sides here. Statement, reason. Oh, write a little bit better than that. Right? So 1, we always start off with our original equation, or statements that are given to us. S minus 5. So pay close attention to what I'm saying, because that's an S, and then the other one's a 5. So they'll get mixed up with my S's and 5's. So remember, this was given. And then we're going to go ahead and use distributive property. Actually, no. We're trying to solve for S. So let me rewrite that. 3.5 S minus 5. I'm going to divide both sides by 3.5. So my second statement will be d over 3.5 equals S minus 5. So that was through division property. And now we're going to move the 5 over. So we're going to add 5 to both sides. So I have d over 3.5 plus 5 equals S. And that was through the addition property of equality. Okay? So we're starting to go into these proofs. Now we're going to be adding more properties and using them. So we have the reflexive property. And the reflexive property says, you kind of look in the mirror and you say, hey, I am myself. And that works for segments as well. So the segment length AB is equal to itself. The measure of angle A is equal to the measure of angle A. So I am myself. And then we have the symmetric property. So when we use that with real numbers, so if A equals B, then we can swap them around. Then B equals A. So that's all the symmetric property is. You just reverse. So if the length of AB is equal to the length of CD, then the length of CD is equal to the length of AB. So I'm just swapping. If the measure of angle A equals the measure of angle B, then the measure of angle B is equal to the measure of angle A. And then here's the transitive property. If A equals B and B equals C, then you can go ahead and say A equals C. Same thing with the segment length. If the length of AB is equal to the length of CD, and CD is equal to the length of EF, then AB is equal to EF. And then lastly, if the measure of angle B, or A, is equal to the measure of angle B, and the measure of angle B is equal to the measure of angle C, then measure of angle A equals measure of angle C. All right, a proof. All right, show that the length of CF is equal to AD. Okay. So this time we're not doing equations, but we're still going to make statements and reason. Okay, so we're trying to show that CF, the length of CF, equals the length of AD. And we don't have any numbers, but they do tell us, they do give us some things. So whenever you're working with a proof, you always want to start off with what you're given. So they tell us here that, so let's use colors. So they tell us that the length from A to B is equal to the length of E to F. Okay, so I'm going to say, so my first statement, AB equals EF. Okay, and I'm also going to combine it with another statement. And the reason is because they have the same reasoning behind it. We have BC equals DE. And the reason for both of these is that they're given. So they're given in the diagram. So always start off with what's given. Okay. So now how do we get to CF equaling AD? Okay. So my goal is to get CF equals AD. So CF is this big piece. So from C to F. And then we want also A to D. Okay. So first off, we need to get CF and AD. So how do I get, so let's start off with AD. How do I get AD? Well, to get AD, I do AB plus BC plus CD, and that'll give me AD. And why are we allowed to do that? That's called the segment addition postulate. Okay. Now, let's look at this one. So how do I get EF? Or no, CF. So how do I get CF? Well, that's just by combining CD plus DE plus EF. And that'll give me CF. Okay? So now we established what AD is and what CF is. Now how do we make them equal to each other? And what I'm writing here is that this is the segment addition postulate again. Okay. So let's say here, now how do I get them to equal each other? So usually when we get stuck like this, we always go back to what they gave us. So they tell us that AB is equal to EF and BC equals to DE. If I look at these equations carefully, I'm actually going to use substitution because they tell us that AB equals EF. So this that I circled in red is AB. And then what I circled in green, so BC equals DE, is BC. So if I rewrite this, I'll have CD plus my green is now BC, and my red is AB, so, and then CF. So what I did there was substitution. So let's see here, that's substitution. Now, does the fourth line look like the second line? It actually looks almost exactly. So, because I have AB, I have BC, and I have CD on the left side, they're all being added together, but I have AD equaling CF. So I can say CF equals AD through substitution property. Because I said CF is equal to AB plus BC plus CD. So therefore, in the second statement, I'm going to replace AB plus BC plus CD with CF. Now, if this whole example was confusing to you, don't worry. We're going to do more later. You're not supposed to be master of proofs after one day. We're going to be working on this all semester. And just know, if you're not a master of proofs by the end of the semester, that's fine. Or even after the year, that's fine. But please try. At the very least, you should know how to do the first statement. First statement is always what you're given, so there's some free points there. And then if you notice, the last step, at least the last statement, is what we're trying to prove. Okay? But basically, we kind of make a logical argument, and it flows all together. So once again, we wanted to show that CF equals AD, so we needed to define what those actually were. Like, how do we get AD? How do we get CF? And then we needed to find a way to show that they were actually equal to each other. So once again, if this was confusing, that's fine. We're going to do more. You're not supposed to be masters of proof until, well, you don't have to be masters of proof this semester or even this year. All right. We'll do some more in the next section. Have a good day.